Mutually inclusive events. In this video, you will learn how to calculate the probability of two mutually inclusive events. Do not forget to subscribe, and if you have any question, feel free to ask or suggest anything. When events have outcomes in common, they are said to be mutually inclusive events, also known as not mutually exclusive. Now let's see what happens when events are mutually inclusive. Example. Suppose we select a card at random from a standard deck of cards. Calculate the probability of the card is a 7 or a queen, the card is a 7 or a heart. Look at the diagram. You should see that 7 and queen are mutually exclusive events. The probability of getting a 7 or a queen is probability of 7 plus probability of a queen. We have 4 queens and we have 4 sevens. After simplifying, we get 2 over 13. Now look at the new diagram. 7 and hearts are not mutually exclusive because we have an intersection between them. They are mutually inclusive events. If we calculate the probability in the same way as we did above, we got a big problem. Take a look. The 7 of hearts appears in the probability of the 7 and in the probability of hearts. We are counting the probability of 7 of hearts twice. We need to subtract the intersection. Otherwise, we are double counting. The probability of 7 or hearts is 16 over 52. It's always true that if A and B are mutually inclusive events, the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Example. In a room with 20 people, there are 4 women wearing red and 6 wearing yellow. And there are 6 men wearing red and 4 wearing green. What is the probability of randomly picking one person who is either wearing red or is male? The number of total outcomes is 20 because in the room there are 20 persons. The number of red is 4 women plus 6 men. The number of men is 6 wearing red plus 4 wearing green. Red and male are mutually inclusive events because there are men wearing red. Six men are wearing red. So the probability of red or male is probability of red plus probability of male minus probability of red and male. After simplifying, we get 7 over 10. Example. Find the probability of getting a number greater than 3 or a multiple of 2 when we throw a die. The number of possible outcomes is 6. The event A is the number greater than 3, and A is 3. The event B is the number of multiple of 2, and B is 3. A and B is 4 and 6. The number of A and B is 2. The probability of A or B is probability of A plus probability of B minus probability of A and B. After simplifying, we get 2 over 3.